This conference will now be recorded.
Okay, once again, very good morning and thanks for joining. This is our second session. Yesterday we discussed about a little bit intro about SQL Server, and we discussed about how the licensing being working in the SQL Server, what kind of licenses are available, and we'll also discuss when we go to the cloud, especially when we go to the cloud. So yesterday we discussed a little bit about on-premises licensing, means whenever you are going to purchase SQL services, okay, what kind of license are available, how much Microsoft is charging, what is the mainstream support, what is the extended supports. That's what yesterday we discussed. When you go to the cloud, especially when you go to the cloud, what kind of licensing, what kind of benefits are available, whether whatever license we purchase in on premises, will this license can be applicable to the cloud or not. So because when you go to the cloud we have two platforms, right? So especially if you go to the uh, Azure cloud, so this is how the cloud portal looks like. Okay, so whenever you try to deploy SQL Server database or managed instance or SQL on Azure VM, so uh, when you just search for SQL, we have too many services. See, SQL database, SQL Server, SQL Elastic Pool, SQL Managed Instance, SQL on virtual machines. So whenever you deploying the SQL over the cloud, okay, how the licensing will work, okay, will the on-premises license will work in a cloud part or not? Everything we'll discuss once we start the cloud part. As of now, we are not discussing anything cloud. Okay, for next 15 to 20 sessions we will strictly will be available in the on premises. Okay, once we almost we done till replication till replication, we will be strictly with the on premises. Later on we'll go to the cloud part whenever we start the clusters on always on. So everything when we are discussing clusters always on, we'll discuss everything over the cloud part. So we will deploy the VMs in the cloud, and we will use the this VMs to deploy the clusters, to deploy the always on, to deploy the load balancers. Everything we'll discuss over the cloud. Make sense in Azure, along with, okay, maybe you may also get a chance to work with the PostgreSQL as we been starting. We will add one or two points in the your resume as well. Okay, so most of the time we will get a chance to work PostgreSQL with the Google Clouds. Okay, so we will also be discussing Google Cloud, how Google Cloud will works. Okay, and how to deploy SQL on the Google Cloud GCP, and how the PostgreSQL will work on the GCP. That's what we will discuss in the GCP as well. Okay, make a sense. So because GCP will work for 3 months, so in case uh, here also same services where GCP is also offering. You can deploy the VMs. Okay, so when you go to the compute engines, you can deploy the VMs, you can deploy the disk, you can deploy the snapshots, you can deploy the SQL, you can deploy the networks. Okay, same how we will do in the Azure cloud. You can also do everything in the GCP cloud. So try to create one GCP cloud and try to deploy the VMs. Okay, and you can also build the always on, you can also build the clusters. Everything you can do in the GCP as well. Okay, in case you feel that Azure cloud will free trial account will expire in 1 month, every month it's very difficult. So again, please don't create any free trial subscription until unless I will confirm you when you supposed to create the free trial. We should not waste the free trial subscriptions. Okay, make a note. Okay, even when you go to our YouTube channel, there is one especially one session. Okay, when we are teaching Azure admin, when we are teaching Azure admin part, we used to teach the site to site connectivity, means how we will make the connectivity between Azure is one site and GCP is one site. How to make the connectivity between these two different sites. Okay, there is one session where we covered, but nowadays we are not teaching Azure admin part. Okay, not that much depth, but basic how we need, how much we need, that is what we are going to cover. So make a habit to use the GCP or AWS or Alibaba Cloud. Not only simply you are working with Azure. Okay, so anyhow, if you are creating a free trial subscription in Azure, you may also get a chance to create the same credit card you can use in the GCP, same credit card you can use in the AWS, same credit card you can use in the Alibaba Cloud. So going forward, you may also get a chance to work with the GCP. You may also get chance with the AWS. You may also get chance with the Alibaba Cloud. Mostly, if most of the time MySQL, PostgreSQL, you will get chance in GCP and Alibaba Cloud. And SQL, either AWS or Azure part. Okay, so we will make one interesting session. Okay, how the VMs will be VM can be deployed in GCP, how the VMs can deployed in AWS, how VM can deployed in the Azure. Anyhow, we are discussing everything in Azure, but apart from this, we will also cover how we will deploy the VMs in AWS, how we will deploy the VMs in the GCP and SQL as well. Okay, makes sense, everyone? Because nowadays we may also getting chance more on AWS as well. So for example, if you are working for UK projects, okay, in case you got a chance to work for UK projects, most of the UK projects they are working with AWS, not with Azure. Okay, so uh, at least you should know about how the AWS dashboard looks like, but almost same. So the services are same, but maybe the deployment process will be different, the templates will be different, dashboards will be different, but almost all the cloud platforms, okay, the services are almost similar. The naming will be different, but the concept is same. Make sense, everyone? Yep.
Yes, sir.
Okay. Now, okay, let's move on to our actual concept what we are planning today. So as a core database administrator, as a core database administrator, either for SQL Server or for Oracle or for PostgreSQL or Sybase, any database management system, we must and should know how internally this database management system, whatever we are learning, that is keep on working internally, how it is working. That is very, very important. That is very, very important. You must and should know. You mustn't, everyone mustn't should know how internally it is working. Okay, so being we are discussing PostgreSQL, so while we are discussing PostgreSQL architecture, I will compare with SQL Server architecture as well, so that easily you can understand how the internal mechanism been working. Okay, that is very, very important. Now, when you just start, okay, so when you go for SQL Server architecture, if you go and search in Google, so for example, one second. Okay, sorry. Yeah. So when you just, for everyone, as a basic part, we'll go search in Google. Okay, SQL Server architecture. When you just search in SQL Server architecture, okay, you will get lot of images, lot of blogs over the internet. Okay, so out of this, let's take couple of images. Okay, images. So one of the most mm, simplest images, this is the one image most of the people will refer whenever you are searching in Google. Okay, so architecture, the architecture remains same for all the SQL Server versions. That is one of the good point. Okay, either you were working with the 2022, 2019, 2017, 2016. Okay, internal architecture remains same, but the external, the features and everything, the algorithms, most of the things has been changed, but internal architecture almost is similar for all the SQL servers versions. So whenever you just open in the Google, you will find a couple of images related to the SQL Server architecture. Even so, when you, for example, if you go and search for Oracle, okay, if you go and search for Oracle architecture diagram, so if you go to the images, you will find Oracle related architecture. So, for example, if you go to this, okay, so this is the image for Oracle architecture, but almost even sequels are also same, but unfortunately, so if you go to this, okay, you can see everything in this picture. You can see everything in the picture, but how the Oracle is working, almost our SQL is also working same. Almost our PostgreSQL is also working same. Almost MySQL is also working same. Almost internally, all the database management systems are working same. But when you open for Oracle architecture, you will get, okay, everything in that architecture diagram. But when you go to the SQL Server, most of the time you will find only this kind of architecture, not in detail architecture. That is one of the, okay, one thing you will see the difference. That is one thing you will see the difference. Okay, so the people who already been working for Oracle, so you can find that much detailed architecture image over for SQL Server, especially for SQL Server. Just make a one note. So now, so when you try to open here, okay, so let's see phase 5 phase. Okay, so when you go to the SQL Server architecture, when you specially go to the SQL Server architecture, you will see three phases. You will see three phases. Okay, here you will see only two phases. One is this phase. Okay, one is this one is this one is this. But if you if you go to a little bit different image, okay, so basically this is one phase, this is one more phase, here again two phases internally, and this is one phase. So a little bit change whenever you go to this image, but follow this image. This is little bit very important. Okay, so now we are going to discuss only these two phases. Okay, on advanced performance tuning we will cover this phase. This is also very very important, you must and should know. Okay, so mostly SQL OS is the topmost layer. So for example, this is our engine. Okay, so this is our engine, SQL engine. Okay, see sir, whenever you are trying to connect, so when you are trying to connect SQL, when you are trying to connect SQL, you will see the database engine. This is our engine, okay, where you are completely working, okay, where you are completely working with this engine only. So when you go to this engine, when you go to this engine, this is again externally you will see only DP engine, but internally there are two engines internally. One is relational engine, one is storage engine. One is relational engine, one is storage engine. That is what here every image is representing. So when you go here, this is your relational engine, this is your storage engine. Here also, this is your relational engine, this is your storage engine. So there will be two engines internally. So that is very important. Just but when you are connecting to the SQL, you will just connect with the database engine. You will just connect with the database engine, but internally there are two engines are available. One is relational engine, one is storage engine. So when you go to the again internally, we have lot of components, we'll discuss in a while. But but okay, so this is our database engine. On top of this, there is one more layer called SQL OS. SQL OS. On top of this, our database engine, there is one more layer that is called SQL OS layer. SQL OS layer, this is very important. This layer is very important actually. So that's the reason this we are going to cover in the advanced performance tuning. Okay, because it contains lot of internal concepts. It's very difficult on the beginning of our sessions to understand that terminologies. Okay, it's very difficult, so that's the reason we are going to discuss in the advanced performance tuning, so that you have a little bit idea about SQL Server, right? We've been discuss almost 30 to 40 days. We'll discuss complete SQL Server. Later on, you can understand about the SQL OS. Okay, make a note. And one more is, okay, assume this is a user or client. So, for example, this is a user or a client. For example, you wanted to read the data. So, take a simple bank, sir, for your understanding. So you are having ICICI Bank or HDFC Bank or SBA Bank or HSBC or Citibank, any bank. For example, you open a bank. You try to log into the portal via app, via Android app or iOS app or from the Google, and you wanted to generate the bank statement. For 6 months you wanted to generate. For 1 year you wanted to generate. For 2 years you wanted to generate. For 10 years you wanted to generate the bank statement. Easily you can understand. So whenever you wanted to read the data, bank statement and nothing but reading the data, right? Yes, everyone, are you there? Yes. So you are trying to read the data. So whenever you are trying to perform read, okay, select. Read is nothing but select star. We'll discuss all these statements in the coming sessions, okay? That's what I told you, right? First 5 to 10 sessions are purely dependency sessions. Please hold little bit, okay? But these are very important internal concepts. So whenever you are trying to see your bank statement, whenever you are trying to see the bank statement from the portal or Android app, so what is happening? So it will try to connect to the database engine internally via network, right? Network layer, correct? Yes. So there is one more layer that is nothing but a network layer. Network layer. Okay. The network layer, DB engine layer, and SQL OS layer. Within that DB engine layer, again two parts. One is relational engine layer, one is storage engine layer. So there are four major things you must and should remember when you specially go to the SQL Server architecture. I not only SQL, sir. If you go to the PostgreSQL, if you go to the Oracle, if you go to the MySQL, definitely there will be, okay, 3 to 4 layers will be available internally. Everyone must and should know about all these layers. Okay, you got one idea. So whenever you are trying to retrieve, whenever you are trying to retrieve a bank statement, so via network, first it is connecting to the SQL OS. From SQL OS, it is connecting to the DB engine and it is spin your everything, and again finally it will send data to the user. If you understand, let's go for internal. We'll see one by one. Okay, now, okay, so when you go to the SQL Server, we will discuss all these parts. Okay, there are lot of services, other services are available, not only SQL Server. Okay, so when you expand here, there is analysis service, there is reporting service, there is integration service. Okay, these three services also very important, which is belong to MSBA technology. I'm not sure how many people know about this technology, MSBA. On MSBA, we will majorly will work with the three services. One is IS, one is AS, one is RS. IS is nothing but Informatica, sir. You everyone know about Informatica, right? How Informatica will works, your IS services also work same. Analysis service only available in the Microsoft. That too in the SQL Server. Analysis and reporting means you are trying to generate the reports like Tableau, Cognos, Power BI, SSRS. All will comes into the reporting services. All will comes into the reporting services. So not only you are our concentrated more on database engine, you also know about IS, AS, RS as well. That is also we are going to cover as part of this training. Okay, how integrate, not development parts, sir. I am not discussing anything development, but as a database administrator, what is our role to maintain all these services? So you need to install, you need to configure, you need to deploy, you need to troubleshoot, you need to migrate, you need to upgrade, you need to grant the permission. Not only our database engine, you must and should know about all these three services. That is also we are going to cover as part of this training. So how to install integration service, how to install analysis service, how to install reporting services, how to configure, how to deploy the packages or cubes, how many ways you can deploy in case your packages are getting failed, cubes are getting failed, where you need to go and see the troubleshoot. If it is related to the DBA, we will troubleshoot. If it is related to the development, we will route the tickets to the development team. They will take care. We are not responsible. So at least you should know about this, right? Whether it is related to the DBA or not. Okay. So we are going to cover these three tools. SSRS we are going to cover, SQL Server reporting services, along with Power BI also we are going to cover. Power BI. Power BI. So from SQL Server 2016, Microsoft released a new tool called Power BI. How to deploy SSRS, how to configure, how to deploy Power BI, how to configure, okay, and how to grant the permission. That is very important. Uh, how to access Power BI's SSRS and how to grant the permission. That is very, very important, sir. All we are going to cover as part of this training. Okay, so not only our database engine, we must and should know about these three tools as a database administrator, because we are the DPAs, right? You are the only one people who will install these services, who will maintain the services. Okay, so if you're just focusing on the database engine, and definitely you will get a chance to work on these three tools as a DBA. So we must and should know about these three tools. That is also we are going to cover as part of this. Yep. Okay. Make a sense, everyone. So and the tools. Okay. Development tools as well. We are going to discuss like how to deploy SSD. Okay. SQL Server. Data tools, how you are going to deploy data tools, how you are going to deploy Visual Studio, how to access the data tools, how to access the Visual Studio. As part of this training we are going to cover, because those are very important concept. If you're just simply learning database engine, going forward you get a chance to work any one of this, then you will definitely face so difficulty. So being that one, we are going to discuss all this part. And basically a simplest is one, a simple tool that we will use like is nothing but SQL Server Management Studio. To work with SQL Server, okay, so why we will love the SQL Server is it's completely graphical user interface. It's completely graphical user interface, sir. So you can install SQL Server Management Studio. Okay, you can install SQL Server Management Studio. This is how the tool looks like, and you can access any instance in this server. So for example, I'm accessing one SQL instance. I'm accessing one more SQL instance. What is instance, how to install, we will see, sir, in going forward. And we can also install, we can connect multiple instance, we can connect multiple instance on the same SSMS. So you can simply call it as a SSMS, SQL Server Management Studio. SQL Server Management Studio. So how to install SQL Server Management Studio, how to access SQL Server Management Studio, and we must and should know about couple of options here, because on our entire SQL Server career, we will mostly connecting tool is SQL Server Management Studio. So you must and should know about more about this tool. You can do lot of wonders with this tool, right? So every day we are connecting this tool, right? You must and should not only, if you're simply learning this database management, okay, DB engine, what about rest? Rest also we must and should know. Okay, make one more point. Now, no. So when you back to our concept, so basically when you just start about SQL Server architecture. Okay, so SQL Server is a Microsoft rdbms that works on the client server architecture. Okay, mostly when you go to the Oracle, when you go to MySQL, when you go to the PostgreSQL, when you go to the SQL Server, all these RDBMS technologies will work with the client and server architecture. So, what is your client? Either it can be app, or it can be portal, or it can be web portals, it can be application portals. Okay, so you are connecting from the portal, or you are connecting from the applications. Okay, you are connecting from the third party tools, okay, to the server. A server is nothing but your SQL server. Server is nothing but your SQL servers. So there will be client, there will be server. So client, it can be your web portals, client can be your application, client can be third party tools. Okay, it can be anything, sir. It can be anything. Your client can be anything, but your server is nothing but your SQL. Being we are working as a SQL, we will strictly with the SQL servers. Okay. So whenever so SQL Server is a Microsoft RDBMS technology that is completely working with the client and server architecture. There will be client, okay, there will be server. This is your client, this is your server. So it is working with the client and server architecture. Client and server architecture. So whenever user is performing anything, so being we are just starting our journey, you know about already how to get the bank statement. So what you will do, we will just download the application, we will connect to that application, we will go to the statement and we will provide the dates and we will try to retrieving. For us it is very easy, but back end what is happening? Getting my point? Till now almost everyone, you will go to the ATM machines, or you will open your Android application or iOS application. Okay, you will download your applications and you are keep on generating the bank statement, right? Yes or no? At least once everyone generated the bank statements.
Yes,
Yes,
sir.
no, yes.
Yes, sir.
So for us it's very easy, right? For us it's very easy, but what is happening in the back end, that is very very important, correct? So now that is what we are going to discuss. Today we are discussing completely about how uh, select statement is working. Sir, again, select is nothing but data retrieval. Data retrieval means you can read the data. You can read the data. Select is nothing but data retrieval. You can read the data. Okay. So today our main focus will be how we are going to reads, how the reads are working. Tomorrow we will see how writes are working. Whenever I am trying to insert or update or delete, how it is working internally. That is what we are going to cover. So now, so whenever you just performing a submit button, when you are going to the statement and when you are selecting so on so here to so on so here, and just click on submit button, what's happening in the back end? That's what we are going to see. Okay, now what will happen means, first it will connect to the, okay, so first it will, one second, sir. Okay, see, let me complete these slides and we'll discuss the same thing, sir. See, this seems a very simple process from front end. That's what I told you, right? From front end it's very easy. Just you will go to the your application, you will choose what so and so date to so and so date, and you will just click on submit. But however, there are multiple process running in the back end to fulfill this requirement. To fulfill this requirement, there is multiple process back end it is working, sir. So Microsoft SQL Server architecture is very complex internal mechanism with three major components. With three major components. What are the three major components, sir? One is the network layer, one is the DB engine layer, one is SQL OS layer. One is SQL OS layer. This is the three engines. three layers, we must and should know how our SQL Server internally is working. For front end, it's very easy. You will just go and click on submit. For back end, what is happening? What is happening? That is what we are going to see. Now, so whenever you, sir, here discussing in a short time of SQL OS, but I will come back again in the advanced layer, advanced performance tuning, in depth of SQL OS. Okay, try to understand. Now, where we are, sorry. So whenever you click on submit, whenever you chosen from so on so date to so on so date, and you just click on submit, whenever you are click on submit, whenever you click on submit, so what is happening? First it will via network, SQL Server network interface, SQL Server network interface. So SQL Server network interface. First, it will make the network connectivity, correct, to your DB engine, to your DB engine, right? So first, your SQL Server network interface establish the network connection network protocols, through network protocols. Via network protocols, it will establish the connection. It will establish the connection to your database engine, to your database engine. We are having three protocols, or one is shared memory, one is named pipes, one is TCP/IP. One is the shared memory, one is the named pipes, one is the TCP/IP. So we are having three protocols. See, so we are having three protocols. When you open SQL Server Configuration Manager, again I will walk through all these concepts, no worries, the first time who are listening. Okay, see sir, we are having three protocols: shared memory, named pipes, and TCP/IP protocol. TCP/IP protocol. Using these three protocols, it will make the connectivity. So once you click on submit button via SQL Server Network Interface Protocols, it will make the connectivity. First point, everyone clear? How it is making connectivity?
Yes, sir.
Via SNI, SQL Server Network Interface Protocol. It is making the connectivity through data to database engine, not to database engine. Either any one of this protocol. It may use shared memory, it may use named pipes, it may use TCP/IP. What is this protocol? We'll see, sir, in the next slides. Okay. First point, everyone clear? In the form of SQL Server use the TDS packets. TDS. Okay, tabular data stream packets. Tabular data stream packets. Actually, this feature came from the Sybase. So still we are using the same feature. We Microsoft is not yet changed. Being Sybase and Microsoft being worked as an data will work for a couple of years to design the SQL Server, right? Out of this, Microsoft took one feature called TDS. Okay, tabular data stream packets, network packets. Being this is the algorithm we are using still now. Okay, till for SQL Server 2022 also we are using the same structure. So TDS is nothing but tabular data stream packets and network packets to make the connectivity. Means your data is transferring via packets, network packets. So same feature been using it. The feature has been inherited from the Sybase actually. Okay, Sybase. So SQL Server Network Interface is the network protocol layer to connect to the database engine, to connect to the database engine. While it is making connectivity, while it is making connectivity, it will use the TDS. It will use the TDS, tabular data stream packets, to make the connectivity to the SQL Server. So we are having three, sir, basically. We are having three. One is shared memory, one is named pipes, one is TCP/IP. Any questions? Any questions? Everyone? Anyone? No? Yes? So what is shared memory, what is named pipes, what is tcp? That is what very important. You must and should know about this. Okay. Shared memory, tcp and named pipes. Basically, sir, in the simple terms, basically take this my laptop. Okay. So treat ssms is one client. Okay, basically ssms is also one client, sir. SSMS is also one client, means SQL Server Management Studio is also a client. SQL Server Management Studio is also a client, and we install SQL Server on the same server. Means SQL is running on the same server. Okay, so SQL is running on the same server. SQL is running on the same server, and SSMS is also on the same server, right? Correct. So SQL Server is also I install in the same server. SSMS is also available in the same server. So when you are making connectivity between these within the same server, within the same server, same server, SQL Server will use shared memory. In a simple for your understanding, SQL Server will use shared memory. How I can believe, Subbu? Okay, let's disable. Okay, let's disable. So I disable TCP/IP, I disable named pipes, and only shared memory is working, enabled. Let me restart the SQL Server, sir. If you make any configuration changes, you need to restart the SQL services. It will affect the configuration. Okay, I'm just restarting the SQL. Now, when you try to connect, okay, okay, done, sir. Now you can disconnect and you can again connect to the SQL Server, sir. See, I'm able to access. Means whenever your client and server, whenever your client and server are in the same mission, or in the same mission, or in the same mission, then default it will use the shared memory. Defaultly it will use the shared memory. Everyone clear? So whenever your client and server on the same mission, defaultly it will use the shared memory. Clear about shared memory, everyone? Yes? No? Are you there?
Yes, sir.
Yes, sir.
Okay. Now, so when you go to the named pipes, so named pipes, you should understand a little bit. Every device there will be LAN port, right? For your laptops, for your desktops. Okay, there will be LAN connectivity, correct? Yes or no?
Yes, sir.
Every laptop there will be LAN.
Definitely.
So whenever your application, whenever your client, whenever your client, for example, ICC is your client or SSMS is your client. Okay, not in within the same server, sir. Whenever, okay, this is in different server. Okay, this is in different server. Your server is in different server, and this is in different server. These two servers are connecting via LAN port. LAN port. Okay, then we will enable the named pipes. Then we will enable the named pipes. Mostly as a best practice, as per best practice, Microsoft best practice, we should not encourage the named pipes. Okay, mostly named pipes will be disabled. You even whenever you get a chance in real world, you can also go and verify named pipes will be disabled state. Always named pipes will be disabled state. But sometimes your application team will come to you and there is a dependency on that application. For that application, they should interact only with the named pipes. Then only we will enable the named pipes. Otherwise, always named pipes will be disabled mode. Always named pipes will be disabled mode. Means whenever your application and SQL is interacting with the LAN cables, okay, then only we will enable named pipes. How we will came to know this, Subbu? Means your application team only come to user. your application team will come to you and they will ask you, hey, there is my application compatibility dependency, you should enable named pipes, then we will enable the named pipes. Otherwise, mostly named pipes will be in the disabled states. Hope you clear, everyone. So whenever you are interacting your SQL Server and your database engine, your client and database engine via LAN cables, then only we will enable the named pipes. Otherwise, it will be disabled. Always it will be in the disabled state. Clear, everyone? Yes? No?
Yes, clear, sir.
Second point. Okay. Finally, widely used protocol is TCP/IP. Even whenever we are learning in the BTech or degree, we came to know TCP/IP networks are network. Okay, remotely in a simple term, remote, remote connections. So, for example, this is your server. Okay, this is your DB server. This is your DB server. DB server. These many are application servers. Means multiple servers, sir, and all the servers are trying to interact with this DB engine. Okay, so when you are connecting remotely via network, when you are connecting remotely via network in the backend, network means not internet connection, sir, network. Okay, when you are connecting remotely in the backend, we will enable the TCP IP protocol, a widely used protocol, sir. So, remotely, in a simple for your understanding, if you are trying to make the connectivity remotely, okay, we will use one and only one protocol, that is nothing but TCP/IP protocol. The default port of TCP protocol is 1433. You mustn't should enable the port 1433. Is the default protocol. You can change it, sir. If you want, you can change it. Okay. What is the default port number of SQL Server? 1433. Actually, that port is for TCP/IP, sir. Okay, but we are calling SQL Server port number. What is the default port number of SQL Server? 1433 is the default port number. Can I change? Yes, sir. You can change it. So if you go to here, right click on here, go to the properties, go to the IP address. You can change the port number. You can change the port number, whatever port number you want. So, for example, I want 1878. You can change it. As a best practice, you should not encourage 1433 port number because that is a default port number. But still, most of the organization is using default port number. But that is also not a best practice. We should not encourage to use default port number. So if you wanted to connect remotely, the widely used protocol is TCP/IP protocol. And what is the port number? 1433 is the one of the most important entry question. And basic interview questions are this is again, it is not highly important, but this is the basic interview question. What is the default port number? What is the port number of SQL Server? 1433. And you will ask one more question. So for example, I am having three SQL servers in the same mission. Can I use same port number for all these three? No, no, sir. When these three instances are in the same server, when these three SQL instances are in the same server, every instance should maintain different port numbers. Different port numbers. Okay, if these three instances are in different servers, assume here one SQL instance, here one SQL instance, here one SQL instance, here one SQL instance, here one SQL instance. You can maintain a single port number for all the SQL instance. But this all instance in the same server, every instance uh, mustn't should follow different port number. This is also one point you should make a note down, sir. Okay, clear, everyone? Yes, no, are you there?
Yes, sir.
Yes, sir.
questions, anything about the network protocols. So if someone is asking what is network protocols, we are having shared memory, TCP/IP, named pipes. Shared memory means if my client and server in the same server, we'll use this defaultly it will use the shared memory. Whenever we are connecting remotely, it will use the TCP/IP protocol. TCP/IP protocol. If we are connecting via LAN cable, we will use the named pipes. And one more protocol is available, sir, but that is duplicated. VIA. VIA. But it is duplicated. No more, sir. Now you won't see. You will see only three. Okay, that feature is already duplicated long back. VIA. Virtual interface adapter. Virtual interface adapter. It is already duplicated. No more. But still, just for your info, sir, VIA is also earlier, like olden days, we are going to use the VIA protocol. If we are trying to connect through via Wi-Fi, then we used to enable VIA protocol. Now no more VIA protocols, sir. Okay, now we are having only three protocols. Okay, everyone. First layer. Any questions about the network layer? Again, I'm repeating. Okay, next to couple of sessions, a little bit get bored. Okay, and you may feel that, oh my God, too much of theoretical part. Yes, sir, completely theoretical part. Okay, little bit be patiency. From next week, it will be more interest. Hope you are getting. I can't do anything. Okay, if I'm skipping this one, uh, then you are not so strong at internal concepts, sir. I hope you are getting my point. If you wanted to become something strong in internal, you must and should know about all these concepts.
Yes, sir. These concepts also interesting.
Yeah, all are very important. First 10 sessions are very, 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 very important. Okay, you must and should know, sir. Lot of theoretical part. Okay, every batch I'm highlighting. Okay, uh, little bit be patiency. You must and should know about the base concepts. This is the base, sir. If you're considering your base so strong, okay, you can keep n number of, okay, pillars are very important. Four pillars are very important. Base concepts are very important, like SQL internals, backups, restores, recovery models are the main pillars. On top of that, you can construct whatever you want. I am not worrying at all. Because if you wanted to configure lock shipping, mirroring, replication, clusters, always on, uh, migrations, upgradations, DB refresh, okay, DB migration, DB upgradation, you must and should know about the backups, you must and should know about the resource, you must and should know about the internal, how it is working. So this is the main four pillars. Later on, it will help you, sir. Okay, now, sir. So everyone clear about the network layer?
Yes, sir.
Why so?
Okay.
Okay, that's what just makes little bit interactive. Uh, you will be little bit encouraged. Okay, uh, feel free to stop me. Feel free to ask. Okay, I can repeat any number of times. We are having lot of time this week. Okay, whole this week we are going to discuss internal only. Whole this week we'll discuss internal concepts. Come on, next. So once you once you make the connectivity, sir, once you make the connectivity to the SQL, the first layer you are trying to connect is database engine. The first layer you are connecting is the database engine. So so database engine is the core component of SQL Server. A database engine is the a core component. This is the core component of entire your SQL Server, sir. This is the core component of entire your SQL Server. where you are going to perform everything. So you are going to create the databases, you can take the backups, you can restore, you can maintain the security, you can maintain the server objects, replication, polybase, always on, management, integration, and you can make the automation, you can create the jobs, alerts, operators, proxies, everything. You can do everything here. Database engine is everything, sir. Everything. So is the one of the core component of an entire your SQL Server, where you are going to perform everything here. Anything you can do it here, sir. So you can create the databases, you can create the logins, grant the permissions, replication, always on, lock shipping, mirroring, everything is working here itself. So database engine is your core component. Everything you can do. On day one, I can't explain everything. So keep on our journey. We'll go step by step, and we will discuss most of the concept here. Whatever here we are, Microsoft is giving the feature set, most of the concepts we will discuss with the live demos. With live demos. Okay. Now, so once you connect to the database engine, so for example, sir, a simple example, when you open new query, okay, the people who don't know anything, we will see, sir, one by one. We not yet completed installation part. Once we complete installation, will again I will walk through all these features. Okay, so for example, if you open a new query, what you can do everything, sir. So for example, I want to read the data. I want to read the data. So for example, select star from sales dot sales order bigger. Okay, I want to read the data. You can execute it. Now you are seeing the data, see. So assume this is your bank statement and you are trying to read. See, you are able to read the data. It contains the sales order ID, sales order detailed ID. So it contains lot of columns and it is trying to providing the data. So this table is little bit bigger, sir. So this table, it may take some time to retrieve the data because this table contains almost 5 billion records. Almost this table size is 5 GB of 5 GB. The table size is 5 GB. It may take some time to retrieve the data. Okay, to retrieve the data. So whenever you performing this one, forget about this one. We'll see what is this one. Session ID. Session ID, sir. From where you are getting this session ID? Okay, if I'm opening one more query window, you are seeing one more ID. If when you are opening one more query window, you are seeing one more ID. So whenever you send a request, for your request, SQL Server will allocate one session ID. SQL Server will allocate one session ID, that you should call it as a SPID. That you should call it as a SPID. From where you are getting, sir? From SQL OS. SQL OS. So this session ID you are getting from the SQL OS. This session ID you are getting from the SQL OS. So once you connect to the SQL Server, you are trying to get one session for you for your request. Either you are performing select statement or insert or update or delete, whatever, sir. You will get one session ID. From where you are getting that session ID means from where you are getting that session ID means from SQL OS, because for this session you need CPU, you need memory, you need IO, correct? Right, sir? Easily you can't get data, right? You need some CPU, you need some memory, you need some IO also, right? So from where you are getting that, who is getting that CPU, who is getting that memory? SQL OS is getting that amount of resources for you. So while it is getting that resources, it is also allocating one session for you. That is nothing but SPID ID, SPID. Got you? So where you are getting this session ID? Now everyone clear, sir? Are you there?
Yes, yes,
Yes.
Okay.
yes.
So
Yes, sir.
as of now, Yeah, as of now,
Sir,
just
SP
remember
means
only.
service provider.
Yes. Sorry.
Yeah, SP means service provider or what?
No, no, not service providers. That's session. Oh, you can call it any name, but just SQL process ID. SQL process ID. You
Okay.
can call it any name, but just it's a SP8 ID. How you are getting, sir? Via SQL OS. For this session ID, it will allocate CPU, it will allocate memory, it will allocate IO. We'll see all this in depth, sir. Just I am briefly I'm explaining. I'm not going for in depth. Okay, not at all going in depth. Okay, I will go in depth in the advanced level. Hope you are understanding because it's a
Yes, sir.
headache concept. Again, if I go headache, then people who are first time listening, they will tell Subbu, I don't want. Definitely. Okay, the people people who are experienced, you can understand. Okay, all this concept, but the people who are starting their journey, a little bit get panic, sir. Okay, I don't want to make that one. Let's go for base concept and touching interesting points and touching interesting. I will touch all the interesting points, sir, but depth I will go in the advanced level. Okay, again I will come back, sir. So let me show you. Uh, I will share all these files to you. No need to prepare anything. I will share all this document to you, sir. You no need to prepare anything. Once you okay, so we already make it lot of documents which will help you a lot. So I will go in depth, okay, of SQL OS. Okay, what is schedulers, what is preemptive schedulers, what is corporate schedulers, what is master slave, okay, what is the thread life cycle, how internally working, what is signal wait time milliseconds, what is SQL OS, what is NUMA, how the NUMA will work in real world, okay, weights, all that stuff will go in depth in the advanced level. No worries at all. Okay, because SQL OS itself it will take 2 to 3 hours to explain for me. It's very difficult to understand now, correct? Because you don't know what is thread, you don't know what is schedulers, you don't know what is preemptive, corporative, master slave, thread life cycles. We don't know anything, sir, correct? If I'm telling right away, it it becomes so challenge for you. Let's keep it in the advanced level so that you know more about SQL Server in next 30 to 35 days, right? Then you can understand what I'm saying in depth knowledge. Yep. Make it sense, everyone? And I will share all these documents at the end of your training, sir. Okay. Now, so you are getting some session ready for you. So SQL OS is allocating some sessions. Here, still it is running. Almost it is taking 6 minutes. And open the task manager, sir. Once, let's see. Open the task manager. Now see, sir. Something is hitting. CPU is hitting 60 to 60% CPU is hitting. Oh my God, memory is hitting 80%. And who is the culprit when you go to the memory, sir? SQL Server. SQL is the culprit. SQL is the one of the most culprit in memory. Okay, so all that stuff, internal stuff, will see sir SQL memory architecture, and I will share the best documents for the memory to remember. Okay, all that stuff going forward, we'll see. Okay, yeah, memory CP is hitting little bit okay, 50 to 60%, but memory is little bit higher, sir. Because I told you right, this table itself is a 5 GB of table. Okay, 5 GB of table. To spin the data, it will take little bit time, sir. Okay, and I am retrieving entire table. All this stuff we'll see, sir, one by one. Now, now, once you connected to the database engine, once it connect to the database engine, now what is happening? Now what is happening? That is what we must and should know, sir. We must and should know about this. We must and should know about this, sir. So once you connect to the DB engine, okay, So once you connect to the DB engine, this is your DB engine. DB engine. So I told you, right, there are two internal engine. One is relational engine, one is storage engine. So DB engine is the main core component, sir. Everything is processing by DB engine. So your transactions, your queries, your sessions, your threads, everything is processing by your database engine. Everything, sir, whatever you are doing in SQL Server is processing by your database engine. Is processing by your database engine. Please make a note down. Now, once it enter into the database engine, first phase it will go to the relational engine. The first phase it will go to the relational engine. See, database engine is the core component architecture. It provides the layer between your client and server OS. Okay, it's the layer between your client OS and server. Okay, SQL Server will contains of or works with the physical architecture. Physical, sir. When you go to the database engine, okay, when you go to the database engine, it is the core component, right? First it will go to the relational engine. First it will go to the relational engine. Under relational engine there are three components. One is parser sorry parser. One is optimizer, miser, and one is executor. Three components. In relational engine there are three components. Whenever you go to any architecture, you will see these three components: parser, optimizer, executor. Even you go here, okay, parser, optimizer, executor. Okay, if you go here also, parser, optimizer, executor. So these three components are belong to the, okay, one second, sir. Yeah, sorry. So when you go to the relational engine, there are three major components. One is command parser, one is query optimizer, and query executor. Okay, let's see, sir. What is command parser? Sir, for example, yeah, it's done, sir. Almost it took 9 minutes 48 seconds. It took 9 minutes 48 seconds to complete, to retrieve, okay, to retrieve 5 billion records. To retrieve 5 billion records, it took almost 9 minutes 48. It is too much time. Okay. But let me, sir, it is not our agenda today. What is our agenda? So, for example, I am writing one select statement. Select set. Okay. So here there is a parser. Okay. Sorry. One second, sir. Okay. Not this one. One second. Okay. Set on. Okay. So for example, sir. So you are writing some select statement. Okay, because we are discussing completely select statement, you should understand little bit concepts, sir. So select star from, okay, emp. So for example, you are writing one select statement. So whenever, if you execute this one, you will get the output. So you will get the output. Currently this table is not available. Okay, let's go for sales order details. So for example, when you run this command, okay, you will get the output. You know that you will get the output because the table is available now. So for example, sir, first whenever you write anything, what you will do, you will check the syntax, right? You will check the syntax, right? Agree, not agree? So so whenever you enable set, sir, you can simply, you no need to enable this set operation. You can simply select this one, and just click on parser. Sir, here see parser. When you check this one, it will check the syntax, whatever you written. Whatever you written, sir. Not only select statement, it can be insert, it can be update, it can be delete, it can be store procedure, it can be function, anything, sir. So when you wanted to check the syntax, you can click on parser. But backend in the relational engine, there is a parser. Correct? There is a parser who is checking your syntax. Who is checking your syntax by default. If you simply execute this one without running this one, without enabling this option, without enabling this option, without running this without selecting this option, if you simply run this one, your relational engine will first check the syntax. Getting my point, everyone? So
Yes,
sir,
sir.
I need to run this one? No need,
Yes,
sir.
sir.
By default, it will check the syntax when you run this operation. When you execute this one, it will check the syntax and it will run. But let me show you, sir, something in a differently. So for example, okay, I am using something. I am using something. Instead of star, I am using something, sir. Run. Okay, execute. Incorrect syntax. It is displaying, sir, when you enable parser only, or you can just select this one and run this one. It will also display same thing. Either you enable this one, or you can directly choose this option also. Fine, sir. It will check the syntax error along with. So for example, with sales equal to at the rate ID. So for example, I am writing simply junk query, sir. Okay, when you run this one, something it is displaying incorrect syntax. So whenever you run anything, so for example, let's take examples. For example, you are trying to connect to the portals, okay, Amazon or Flipkart or anything, and you by mistakenly you provided incorrect email address. It is providing incorrect email address, right? Yes or no? Invalid email address. How you where from where you are getting? From parser only, right? Invalid email address. You can compare, sir. Easily you can understand. Whenever you are connecting to the any portal, if you are providing invalid email address, you will get one pop-up called invalid email address. Getting? From where you are getting? Parser? Yes? No? Come on, sir.
Yes, yes,
Yes, sir.
yes.
Yes. Yes. Okay. Now, so command parser will check the syntax checks. Now everyone clear? What parser will do, sir? Parser will check the syntax. Parser will check the syntax. Clear? Not clear, everyone? Okay, now, so for example, sir. Okay, now when I run this one, you will get the output. Okay, now I am maintaining one ID, one column, sir. Okay, this column is not available. See, sir, when you run this one, okay, when you run this select statement, this table contains only these columns. But what I'm going to do, I am mentioning a column which is not available here. For example, sir, just example. Okay, when you check the syntax, it will show syntax is correct. Syntax is correct, sir. Syntax is correct. But that column is not available, right? So your parser doesn't know anything. Your parser will just check the syntax. Your parser will just check the syntax. Apart from nothing else, it will do, sir. Apart from nothing else, it will do. Once your syntax checks is done, then it will prepare the query tree, that binding. Okay, that is very important, sir. It will prepare the query tree. Okay, It will prepare the query tree. Once your syntax is done, once your command parser check the syntax, once your command parser check the syntax, then it will bind internally your SQL server will bind the query and prepare the query tree, because it is a high level. This is a high level where SQL can't understand. So it will convert this high level to low level language. It will convert this high level to low level language by preparing the query tree, by binding. So when it is preparing the query tree internally, what is the table you are retrieving? What is the column you are retrieving? Now it will get the information. Now it will get the information whether this column is available or not, whether this table is available or not, whether the SP is available or not, whether these functions are available or not. Now it will get, now it will get this that information, sir. If you wanted to check that information, okay, you should enable set. Okay, let me off the parser, sir. I don't want parser now. Okay, let's enable fmt only. Okay, on. So when you enable this one, this is duplicated, sir. Okay, but you won't do all this stuff in real world again. This is for your knowledge purpose, sir. Again, you won't do all this stuff again. You will just use this parser. That's it. We will run the command. That's it. Okay, but now if you run the same statement, now it will displaying invalid column name. Are you able to see, everyone? Everyone? Your parser
Yes,
is
sir.
not showing anything,
Yes.
sir. But when you enable FMT binding, now it is binding, sir. Okay, parser is done. Okay, syntax check is done. The next phase is binding. What do you mean by bindings, Subbu? Means it is checking the objects, it is checking the columns, it is checking your conditions, it is checking lot of things in the backend. So that is the binding. So once it bind, now it prepared the query tree. That's technically doing next step, sir. In the command parser itself, once it checks the syntax checks, once your syntax checks is passed, it will bind the query and prepare the query tree. Prepare the query tree where your SQL can understand, converting high level to low level language. I hope you understand, sir. Now in the binding, while it is binding, it will check whether the columns are available or not, whether the tables are available or not, whether you properly designed everything or not. Okay, now it will check everything. That you can check with this command, but mostly we never run this command in real world, sir. Okay, mostly we never run, but I just wanted to show you in a realistic way. That's the reason I just enable, but you never do all this stuff in real world. Hope you understand how it is binding the statement. So once it bind, now once it prepared the tree, okay, we'll see depth, sir, in going forward. As of now, just remember only this terminology. Once the tree will go to the optimizer. Okay, syntax and query tree by binding. Once it is done, it will go to the optimizer. Now, as of now, today we are going to discuss optimizer only for 5 minutes, sir. Again, I will come back in advanced level to discuss almost 2 to 3 hours. I need to discuss only on optimizer, because optimizer is the heart for SQL Server. I can't discuss lot about in right away now, because it is a main pillar in entire your database engine. Optimizer, optimizer, sir. Okay, now we are discussing only little bit, but I will come back again to discuss a lot about optimizer. Okay, make a sense? So once your query tree is prepared, it will go to the optimizer. What optimizer will do? Optimizer will start preparing the plan, preparing the plan, a plan. So for example, user, generic example, not a technical example. You or your family or your friends decided for one trip, for one vacation. Definitely will plan before 10 days, right? Correct? what is the budget, how many places I need to visit, and what is the transportation way, okay, where I need to stay, what is the cost, okay, what is the you will do one best plan, right? Yes or no? You will make one or two plans. Out of this you will decide and you will choose one best plan, right? Correct? Come on, sir. Little bit encourage, okay? Yes.
Yes, yes,
So that
yes,
I feel that you are understanding. So you will plan, right? Definitely, sir. Throughout your journey, you will
Yes.
already plan for multiple. Like same optimizer will also prepare a plan for your query, sir. For your query. So our plan, when we are preparing plan, money is our cost. Correct? Money is our so important. Like for optimizer, what is important, sir? CPU, memory, IO is a cost. Correct? How much CPU I need to allocate, how much memory I need to allocate. So for optimizer point of view, this is the cost. So optimizer optimizer will prepare the plan based on the cost, based on the selectivity. Very, very important, sir. These two terminologies. Make a note. I am just discussing only for this, only these two concepts. It's simplest. Again, I will come back with live demos. Okay. So your optimizer will prepare the plan. Will prepare the plan based on the cost, based on the selectivity. How much data you are trying to select. How much data you are trying to select, and it will prepare the a plan. It will prepare the a plan. Once the plan is prepared, so clears our optimizer, everyone. So what optimizer will do, once the query tree enter into the optimizer, based on the algorithm, based on the structure, it will prepare the a plan. It will prepare the a plan. How super sir means, okay. So for example, how means uh, 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 so now if I run this one, oh sorry, turn it off. I need to turn it off. Sorry sir, I need to turn it off. Okay, now if I run this one, okay, now it will preparing some plan. See sir, now it prepared the plan. This is how your plan looks like. Okay, the plan cost is 100% and this many operators are available. It is going to the parallelism, okay, and it is performing cluster index scan. It is using sort operator. It is using compute scalars a lot. It is how this is how the plan will be prepared, and that plan will be stored in the plan cache. Sorry, that plan will be stored in the plan cache, in the RAM, in the buffer, in the buffer. Or next time if you are using next time if you are running same thing, so it won't prepare sir, because already the plan is prepared. It will use the same plan. It will use the same plan next time when you run this query. That is how optimizer will do, sir. So optimizer will prepare the a plan, a best plan based on the cost, based on the selectivity. Based on the cost, based on the selectivity, your optimizer will prepare the execution plan. Questions open to you, sir. Again, I am not going for deeper. I will go deeper in the advanced level. Questions? Clear? Not clear? Okay. So once the plan is prepared by the optimizer, then it will go to the executor. It will go to the executor. Whatever the plan optimizer picked, right? That plan will try to execute by the executor. But in relational engine, there is no data. In relational engine, there is no data, sir. So in relational engine, what is majorly performing? Checking the syntax, binding the request, preparing the query tree, and preparing the plan, and going to the executor. It's just doing this operations. Apart from nothing else, it is doing. Nothing else it is doing, sir. Once once your executor got the plan to execute the query, but there is no data. Now what executor will do? Executor will send request to the storage engine. Now the picture will start from the storage engine. Now the picture will start from the storage engine. Okay. Now your executor will send request to the access method. It sends request to the access method. It sends request to the access method. Who, sir? Your executor will send request to the access method. Hey, access method, I got so and so request from so and so user. Will you please provide me the data? Not like that, sir. I'm just explaining to understand. So, will you provide me the data? So, now access method contains multiple APIs. It's a storage engine, sir. Now, whatever we are discussing, everything belong to the storage engine. Storage engine. This is the main, sir, actually, main pillar. Okay, under storage engine there are lot of components. Under storage engine there are lot of components like transaction, file manager, buffer manager, lock manager, lots, sir, lots. Cache. Storage engine is nothing but buffer is nothing but ram, sir, ram. Okay, lot of caches are available. So on that, first it will go to the access method. Okay, so access method contains multiple APIs. Access method contains multiple APIs. Application programming interfaces. Application program interface which can understand easily. Okay, it can understand, okay, what sort of request. For your example, whether it is a select statement or whether it is a non-select statement. Simple for your understanding purpose, sir. So access method contains multiple APIs which can understand whether it is a select statement or whether it is a non-select statement. Whether it is a select statement or non-select statement. Today we are going to discuss about select statement. Tomorrow we'll discuss about non-select statement. Is it fine, sir, everyone? Okay.
Yes, sir.
So
Yes, sir.
now, now, now we are reading the data. Select is nothing but reading the data, sir. Okay. Now access method understood. Okay. User is requesting data. User is requesting data. Okay. Data. Now access method sends request to the buffer manager. Access method sends request to the buffer manager. Where is that? What is that image? Yeah. Access method sends request to the buffer manager. Buffer manager is nothing but RAM. RAM, sir, RAM. Buffer manager. Okay, RAM. So in buffer manager, in buffer manager, this is your buffer manager. Buffer manager is nothing but RAM. Okay, in buffer manager there are pools, buffer pools, buffer pools. Under buffer pool there is a data cache. Tomorrow we'll see all that in depth, sir. Data cache, data cache. Okay, plan cache, log cache, log cache. There are lot of cache. This is plan cache. This is log cache. This is log cache. Log cache. Okay, there are lot of caches are available. Lot of caches are available in the buffer pool. Okay, once your access method sends request to the buffer manager will request to the buffer pool will connect to the data cache, whether your data is available. What is our data? Select star from emp where employee name equal to Shiva. Okay, I am trying to read the Shiva's data. So currently any data is available in the data cache, sir? Any data is available in the data cache? No, right? Yes, no. Currently nothing is available. Now what it will do? It will go to the database. It will go to the database. Your from RAM, it will connect to the database to get the data. So it will connect to the database. It will connect to the database AdventureWorks 2014. It will connect to the database and get the data from the database, and it will place one copy here. Same copy will send to the user. Same copy will send to the user. Now user can see the data. That is what internally happening, sir. Whenever you run a single select statement, first it will go to the command parser, then it will bind the request, it will prepare the query tree, it will prepare the plan. That plan will be stored in the plan cache, and it will go to the executor. Your executor will send a request to the access method in the storage engine. Your access method can understand whether it is a select statement, non-select statement. Your access method will send a request to the buffer manager. A buffer manager will send a request to the buffer pools. A buffer pool contains lot of caches. Out of this is the primary, sir. This is the main data cache. Okay, it will go to the data cache. It will verify whether this data is available. If not, it will get the data from database. It will place one copy in the data cache, and same data will send to the user. That is select, how it is working, sir. Tomorrow we are discussing non-select statement. You will become stronger in internal. You should bear me 2 more sessions to understand a little bit more on architecture. Now, questions, sir. Open to you. Questions? No? Yes?
Sir, what is format only, sir? Just you told before.
Oh, it will bind, sir. See, basically when you parsing, it will just parse syntax checks. But if you wanted to check whether binding information, binding means whether the column is available or not, table is available or
Okay.
not. Okay, that thing you will get it FMT only.
Okay.
But that
But
is
parse only check the syntax of the
syntax. It won't
letters.
check whether the column is available or nothing.
Okay. Thank you, sir.
Questions? No? Yes? Okay, if nothing, yeah, thank you. See you tomorrow.
Yeah, thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Yeah, see you tomorrow. So we'll start tomorrow how writes will happen, like inserts or updates or delete. Okay? Yeah. Thank you, sir.
Okay, sir. Bye.
Yeah, bye.